Well, in fitting fashion, I'm going to produce to you in British nomenclature a stonking good opportunity. I'd like to share with you briefly today around the work that we are doing at Adaptavate to rethink the material flows in the construction sector. The way in which we're doing that is taking renewable feedstocks that are grown year on year that would be otherwise a waste or a byproduct of the agricultural food crops. And we take those and we process them into high-performing, renewable and mainstreamable construction products. We believe this has the potential to disrupt the construction sector materials and is a future-proofing for our industry. So a great opportunity. The reason I'm here today is to meet all you wonderful people, and thank you very much to Robert for the opportunity. But we are looking for production partners across the world to partner with, license to, and collaborate with to bring this rather exciting innovation that I'm about to demonstrate to you to market. So our first product, and the product that's in question today, is breatherboard. Breatherboard is a direct alternative to wallboard. I used to be a builder, as Robert just thank you. Robert just alluded to. So the design brief for this product was born from on-site problems. It was born from the cost of the waste of plasterboard. It was born from, okay, we need to have a solution here that is installed and used in exactly the same way. And I think you spoke about that also earlier, Alberto. We need an on-site applicable solution here. Breatherboard is around 60 to 70% organic matter, so that's the bio feedstock that I'm talking about. It's installed in exactly the same way, but it has some pretty cool benefits, and I'm going to go into that about its in-use benefits. It comes in, we aim to produce in exactly the same dimensions, and it has comparable certification standards, so we test to British standard, European norm 520, which is that of wallboard. So why do we use biomaterials? Why are we thinking about stuff that people haven't used in construction materials for millennia? Well, they have. This is what we use. 60 to 70% of the volume of our material is biomaterials such as this. It can improve the thermal performance, reducing the thermal conductivity, so giving it a better insulating factor in comparison to standard wallboards. It's a lighter material, so from on-site point of view, it's really easy to install. It's also good from a transportation point of view. This breatherboard has a density of around 650 kilograms per meters cubed, but that can be, altered depending on the formulation. It has lungs to breathe, so this stuff that we put in it is not only renewable and all these other things, but it actually gives the material lungs to breathe. And I'll come on to that in a minute. That's why we called it breatherboard. It's renewable, so unlike wood is a great material because it is renewable, we can grow it. But it's a 30 to 40 year cycle, I think you'd agree, wouldn't you, Peter? More or less. And what's with this stuff is that, of course, you can grow this year on year. It's a byproduct of food and crops. It's completely compostable, so our materials at the end of their life are actually nutrients to the soil, not charged to be taken away. Big difference. And it has international scalability because we can use food crops that are from lots of places in the world. And that is exactly why I want to talk to people from all over the world here today, if this has applicability for market growth in your area. So I'm going to run through a bit of an introduction to Adaptavate. I've kind of done that really. The challenges that breatherboard addresses, its performance characteristics, some of the market opportunities, and then I'm going to have a look at the benefits of the production process because I am looking to speak to production partners, and some of the next steps. So my story started on site. I was a builder. I was I want to create impact. I want to change things, but you can't do that one building by one building. This was a big problem I saw in the fact that skips full of plasterboard waste in the UK you get charged to take away that waste. I was kind of like, why is that? You know, not really knowing. I did a bit more digging. I was studying for my master's at the time. I chose to write an essay on it. And you then realise some of the issues around the disposal of plasterboard and other wall boards, around it being mixed with organic matter and water and whatnot, and it being, you know, off-gassing certain gases. I thought, right, okay, well, wouldn't it be interesting if we could design a completely compostable, you know, let's look towards the future. Could we design a completely compostable version of this, but still be installed in exactly the same way? There's 3 million tons of plasterboard waste per year in Europe, and the regulations on this are getting tighter, and we all know that regulations can drive behaviour. It is for the UK specifically, around 50% of waste that goes to landfill is actually directly or indirectly from the construction sector. So, you know, for a small island with really bad fish and chips, or depending on if you like this sort of thing, we're running out of spaces to put this stuff, right? Or just generally stuff that goes to landfill. You know, we have a very take, make, waste approach. What we're trying to do is actually think about this in a more circular way. And I think we all know the security and issues and longevity of the feedstock with synthetic gypsum for the wallboard market, and how, you know, the industry is looking for alternatives. It's kind of what we're hearing around the place. And where do we go? We know there's significant opportunities, but we also know there's some threats to the industry. And I think the conference the synthetic gypsum conference that Robert had a couple of years ago, you know, the big players are concerning themselves with this. Okay, so let's look at about this in-use problems. That's around the supply chain and whatnot. But let's have a look at its in-use issues. So, I mean, again, Europe-centric a little bit, but I think it's across the world predominantly. We're looking to increase the airtightness of buildings. We need to be more energy efficient, and we can improve the airtightness and increase the thermal performance of the building fabric. But I was quite staggered by this. An average family produces 14 litres of moisture per day, just from cooking, cleaning, breathing, dogs barking, whatever it is. 14 litres of moisture a day. Now, in days gone by, that would have just escaped through the gaps in the building fabric, because that's how we build. But as we improve the air tightness to keep hot air in, this moisture no longer has a home to go. We're needing mechanical ventilation, which is an ongoing energy demand, to be able to get rid of that. This moisture can, of course, lead to condensation and mould, and that ain't good for no one. In UK alone, there's 5.4 million asthmatics, and this is mental to consider because we spend, on average, 90% of our time indoors. So we have to make these places healthy, as well as, you know, cost effective and, you know, good value, but also this is where we bring our families up. It's our third skin, to get into it philosophically, if we like. But there's also an issue around volatile organic compounds. So a lot of the materials we've mentioned, you know, VOCs have come up a lot over the last few days. There can actually be 10 times the amount of pollutants in our lounges than in a city centre. It's quite staggering, but the off-gassing is also a consideration. This is not pointing the finger. This is just a challenge that we face. So, okay, let's have a look at breatherboard. We've developed breatherboard to be a high-performing, direct drop-in alternative to other wallboard materials. Let's be clear, it's an internal board, not an external board. It's higher performing in use. That's on a thermal parameter, so it has a thermal conductivity of 0.07, 0.08 watts per meters Kelvin for a lambda value. It has a really good acoustic value as well. Not quite as good as your wood wall boards, but it has a benefit over other wall boards. And then it has this thing that's called moisture buffering, and I'm going to get into this in a bit more detail, but basically this absorption, desorption of vapor in the building fabric. It absorbs pollutants from the air. It's totally compostable, so it's a nutrient at the end of its life, not a pollutant. And it has a comparable fire rating with plasterboard. it's also made from this renewable feedstock. As I say, it was absolutely imperative that we design this product to be installed in exactly the same way, and that's exactly what we found with our in our project with the UK Green Building Council in Shaw Street, which is just across town. Commercial project there where they were really looking at the carbon footprint of the building, and the chaps on site. We played a little bit of a game with them, which was fine with the site manager. We sort of said, is it okay if we just bring a pallet on? I mean, we'd gone through the contracting process and it was painful. I'm not just pitching up and putting a pallet of material on site. We put a pallet of material on site without giving any training to the chaps. And these guys then installed this product and they used it. Our boards were smaller at the time because we were sort of making smaller boards by hand. And these chaps just installed it, picked it up, started cutting it, drilling it, putting the details around, cutting out the surfaces, just like regular boards. Rob said, and then we asked them afterwards, and we said, well, how did you find that material? He said, well, yes, it's a bit different to standard. I could tell it was different, but it was just like that to install. It was great, So from a practical on-site point of view, that's a really good validation point for us. And then also Bar Gazetta's architect practice in town again in London. They were the main architects on this project with the UK Green Building Council, and they were drawn to our materials because they're low carbon, they're recyclable, but they have the potential to have a real positive impact in health and well-being, and they were easy to install. The commercial director of the UK Green Building Council was saying, actually, these guys, we can hit our low carbon targets because they are driven by that, but not compromising, performance or installability, or it just looks like wallboard, as well. Like we can just paint it and it just looks exactly the same. So when we look at Breatherboard in action, it's called Breatherboard because it breathes with the people in the building. So it's thinking about this kind of fabric first approach. And what we can see here is that if we use Breatherboard in the system here, what's happening is that bio feedstock that I introduced you to at the front, at the start of the presentation, that's these sort of little bits here. And they act as the lungs. And they absorb this moisture because our moisture goes like this throughout the day. Essentially, we have two peaks when we're in the house. And the moisture is absorbed into the fabric of the building, into the porous structure of this material. And then when we go to work or we go to sleep, it's breathed back out. No need for energy, no need for mechanical ventilation. This is actually for our breather plaster product because we have a plaster that's currently on the market that is compatible with it. And what that does, of course, is reduce this problem of condensation and mould. I don't know what your markets are like, but I know mould and condensation is a big problem throughout Europe. It also happens that this process also means that we actually absorb and sequester volatile organic compounds, and the Building Research Establishment independent test house has quantified that we are a significant sink of VOCs. If we look at this, its ability through standardized laboratory testing, again independent, you can actually start to see that this is the third stage after the relative humidity in a chamber has been increased and decreased. And then what you do is you switch the RH off, you switch the source of the moisture off, and you see how the material responds. I mean, you can quite clearly see here that this is a standard wallboard, and these are two formulations of ours. This is more or less our current this is our formulation, and you can see that there's 5 times the amount of moisture measured in grams per meter squared. So moisture vapor, not free water, moisture vapor, absorbed by our material. The clever bit is that it actually desorbs as well, because actually you just end up with a very soggy board, and that wouldn't be very good for anyone. If we look at this acoustically again with the ITRI, independent test house, we can see across many frequencies, but particularly the lower frequencies and the higher frequencies, various 1, 2, 3. These guys, red, grey, and blue are various formulations using air compounds and composites. And then the yellow guy along the bottom here is a standard wallboard. And you can see that particularly at lower and higher frequencies, for a like-for-like product, we have a superior acoustic performance, which is really important, I guess, in tenanted properties, sound transfer through walls. You may be able to lightweight some of those structures, that sort of thing. If we look at this now from a production process point of view, and really kind of talking to the producers in the room, from a features and benefits point of view here, it's a really quite low water demand. Our water content is 40 to 50% of our wet material. We really work hard to reduce that, and not by using lots and lots of additives. It's a low additive mixture. This has a massive effect on the commercial case, of course, because it's reduction in drying energy, reduction in hardening time. You've got less water in there, which costs some pennies or euro cents, but it leads to a shortening of our cast to cut time as well. There's no need for high energy processes in this, so we're not doing lots of high energy processes up in the front end. We buy our materials in. We might need to refine some of the crop waste in that front end process, but that's kind of pretty standard off the shelf solution. There's no high energy drying at the back end of the process, so there's a reduction in both capex and opex through that feature. There's low pressure forming, again, reducing energy demand per unit. I already talked to you about the low heating temperatures for drying. There's a renewable feedstock, and it's reliably renewable as well, like year on year. And we've done some good work on securing long-term contracts for that sort of thing. But those different feedstocks might alter for your different geographies. That presents a really good, scalable, local model to be able to think about how we manufacture that in the future across the world. And it's a scalable process, as I say, transferable to international locations. So let's look at the market opportunity. The market opportunity for the wallboard market, we know there's a compound annual growth rate, 5.7%. That's widely documented across in the literature. It's growing. We know that there's increased demand. But there's one of the big growth areas of that, and one of the drivers of that is the increase in sustainable construction methods and of things like LEED, of BREEAM, of whatever the one is in Australia, I can't remember. Is it LEED? Yeah. Anyhow, these more sustainable regulations that are coming in and drivers, and that's creating growth in the plasterboard market. Our sandboard market, again, reasonable compound annual growth rate. 6.7 to 6.1%. It's growing. We know that. That's due to, and we've seen this a lot this week, these last couple of days, is the use of the cement boards indoors, as Peter was very well demonstrating. Fire resistance, we know that, but also some of the more waterproofing additives that we've seen over the last couple of days as well, and that's leading to kind of the kind of CAGR of 6.1% there. One of the most sizable areas of growth is the sustainable construction materials, and that's got a compound annual growth rate of about 11%, 12%, and that's around increase in awareness, client demand, and we're seeing that. That's why we're seeing some of these alternative products on being shown here. There's a higher asset value of green buildings. That's not quite recognised, I don't think, in the market yet, but it's improving. There's a reduction of operational costs, that is a big driver, but also well-being and productivity. For companies in a commercial setting, if companies, 90 to 95% of their operating costs is not the energy of their building, it's actually the productivity of their staff. And the well-being and how they feel within these areas is actually directly affecting their bottom line. So if we can create products that help to improve that, that's good as well. We know the global demand for synthetic gypsum is increasing. Currently, the European production is around 19 million tonnes of synthetic gypsum, 19 million tonnes. We also know that there's some reduction in the coal as an energy provision measure, down to about 2 to 15%. We don't, it's all quite loose and vague at the moment. But the production of this synthetic gypsum is, of course, looks like it's going to reduce, and recycled gypsum can help to ease that. But how much? There are some technical constraints about that. So really, what I'm trying to provide is a solution that is exactly like plasterboard, higher performing, but is devoid of the supply chain, if that's attractive to some of the players in the market. And people are always going to ask about price, so I'll put it. I'll be upfront. That's always going to happen. We have a really attractive commercial case, and I'll go into that in a bit more detail in a later slide. But basically, where we're aiming to sit and where the commercial case really stacks up is in between plasterboard and Fermacell and wood wall boards. These figures are reasonably accurate for the UK market. They will differ. But in principle, we aim to hit market around £7.50 per metre squared RRP, accounting for your merchant and distributor as well. And you can see that we really are aiming at being the highest performing, cost competitive alternative to wall boards. I think that demonstrates that. The technology we've developed is not just around. It's not just boards that this could be used for, it could be used for lots of different materials that could have some of these performance. On here we've got ceiling tiles, we've got acoustic panels. I really love the stuff that you're doing with wood wall boards around the kind of really funky designs and how that kind of can lead to greater market share. I think that's really good thinking. And then the blocks, and then looking at, we haven't spoken much about it, but structurally insulated panels. In the UK, we're all kind of going, yeah, it's going to be prefab homes, we're just going to be slotting together like Lego. This could have some applications in this, a completely compostable home, for instance. So where we're at is that we've scientifically developed this product in accordance with the British Standard European Norm 520, which is that of plasterboard, so it's constantly being referred back to that standard. We've worked with some of the largest independent line producers in Europe to be able to get some initial layouts and concepts on that line. And we have had a high international market interest in the product itself. What we're looking for, and we've also installed this product in projects, what we're looking for is production partners in various locations. And I would be really interested in talking to you either if we have time today or in the future. Our proposition is around, we think, a 1 million board a year plant with a potential to be able to 6 times increase the output of that due to various improving the setting times. Is a good market entry point. We've spoken to internationally renowned line producers, as I've said, and we have a good idea about where the pressure points come on that. We've de-risked the technology, it's scientifically validated. We understand how the formulation affects the industrial process and that balance between that and the end product performance. And we would like to produce a flexible line that is capable of producing a number of different products and types of products through that. We've estimated initially an investment around 6 to 10 million for this 1 million board plant. This of course goes down if you have the land and an ability to house this facility. And with our commercial case that I was demonstrating earlier at that price point of £7.50, more or less, the return on investment is below 4 years. If you have your own space and you'd like to put a breather board plant in an existing building, that dramatically drops to below 3 years. So There's a future-proofing technology here that we have that we're looking for collaborators to get involved with. I need to continue our search for industrial partners, and if you are someone that this sounds attractive to, or you know this might be attractive to one of your clients, customers, associates, colleagues, then please do take my contact details, pass them on. And I thank you very much. May you have lovely journeys on to wherever you may be going, and I enjoyed presenting this opportunity. Thank you.
Thank you very much indeed, Thomas, for an interesting presentation, something a little bit different for the conference. We have a blizzard of questions for you. What about mold resistance? Any additives used?
Yeah, so the natural pH of the composite is extremely alkaline, so it inhibits mold growth. It can't grow.
Okay, so you don't need to use any kind of biocide to inhibit mold growth. Okay. It actually hasn't been asked here, but the obvious question is, what are you using as a binder? Oh, sorry, somebody's asked. What binder is used?
It's lime and natural cement, which is why I got the gate. Got the pass to come. You were allowed me.
Yeah, it's lime.
Lime as a sort of filler,
yeah.
And natural cement as the active binder.
Okay, another question is, Victoria sink gets the material saturated at a certain time. This is an obvious example of autocorrect doing a bad job. Victoria sink means VOC sink, I think. So if it's a sink for VOCs,
yeah.
Does it actually become saturated up?
Yeah, and I don't actually have the answer to that, if I'm being honest. We know it's a significant sink of VOCs. What we don't know is when that's full. We do know that ionically the binder is changing, is altering the VOCs. But we don't know, as I say, I don't have the information to say it would take 10 years. What I do know is that materials like this have been used for millennia. We have repurposed quite an antiquated, the foundation of this is quite an historic material that's been repurposed into a contemporary product for the mainstream use in the construction sector, and that these materials have been used ongoing for hundreds and hundreds of years. That's not scientific, it's qualitative, but that's...
Okay, another couple of quick questions. How does it react with vermin or insects?
It's a board, it's 12.5 millimeters thick. If you've got, it's insect proof. It's because it's got such a caustic environment in there, you don't have any issues with that.
Have you tried it out in somewhere like Miami? Where even the
no, but I'm more than open to those sorts of suggestions.
Where even the 5-star hotels have cockroaches.
Yeah. I mean, the worst that's going to happen is that the cockroach is going to eat the board. I mean, I think I'd probably be concerned about smaller insects getting, into it. But the porous structure of it is so small that the insects can't get into it. That it's microporous structure. So again, you touched on it with the wood wall boards, which was around the Bio-bit being a market switch off. And what we do is, I'm telling you it's a bio-composite board, but the way in which we communicate our products is around performance and health. It's not around sustainability and eco. And we see that enabling us to be able to get greater market share and be able to be more effective at communication, because people aren't switched. It's a small niche that's switched on about eco stuff. So, all our branding, it was green and quite hand-drawn. I have an example of an old logo, but now it's more about performance, health, and that we see is certainly overcoming some of those challenges.
Okay, next question. How does it act in a wet environment? It's not designed for a wet environment, is it?
Well, it's designed for a damp environment, but it's not a tile backer or something like that. No.
Okay.
So you would use it, typically you would use it in your bathrooms or kitchens or lounges because it's absorbing that moisture.
And once it's absorbed all of that moisture, how does it perform?
Because that's kind of what I was saying earlier, which is the moisture regime at home goes very high when we're cooking in the morning and getting up and doing all that sort of thing. We go to work, we go to sleep, and it reduces, and that's when it breathes it back out.
Right, okay.
We also have a lower relative humidity when we go to sleep, so the materials all breathe out, and that's just down to a concentration gradient.
Okay, so essentially you require there to be a drying out phase for the board to work properly. So it's not suitable for an environment where there's never a drying out phase.
No. So things like museums, they have a different profile because they have a 12-hour high of moisture and they have a 12-hour low of moisture. And there are challenges around those sorts of environments. As with all the materials we've spoken about, it's not one size fits all. I'm not pretending this is the big solution to everything that you've ever thought about in the wallboard industry. It's merely, it can be used in various applications.
Okay, Thomas, one word answer. Does it smell?
Doesn't everything?
That's more than one word.
I'm sorry.
What about paint or coating added when you compost it?
Paint or coating. Okay, so
briefly,
paints are water-based emulsions are breathable. The paint industry has worked really hard, particularly in Europe, to take out all of those heavy minerals in the paints, and they've done a lot of good work at stripping some of that stuff out. There is probably going to be an issue of leaching. We suggest through our specification that you use a certain type of paint. It's by no means prescription. But our plaster, along with our board, is entirely compostable, as are other, natural plasters.
Okay, so it's fully compostable depending on the paint or coating that is used in its application.
But most paints are okay.
How to avoid composting during lifetime? I think there's a question about what happens if it gets too damp.
It's different. It's a different environment.
Okay, is the board a paper surface board?
Yep.
Okay, and this question is from me. You say on your slide that gypsum wallboard has low circularity. I think that's not correct because gypsum wallboards are infinitely recyclable.
Okay.
And I think that's extremely well known. Any questions from the floor in the real world? Please, Peter.
If we invest in such a plant for 6 or 10 million euro, how do you secure the supply chain of the raw material?
Yeah, so the raw material, we would, as part of due diligence, partnership creation, we would look at your market area, we would secure some of the long-term ongoing contracts for the bio feedstock within that area. So we'd quantify that, and that would be quite simple to quantify the benefits of those materials in that area. We would secure the long-term contracts. Besides that, there's essentially our main binder and the lime that we use within it. That's easy. We're also very fortunate to work with one of the leading independent paper producers, and we have a longevity of that supply as well. Besides that, there's not much else. So as part of the front up work, we would do that to quantify what the feedstock was and secure those contracts moving forward.
Okay, so I think we've seen a very, very interesting alternatives to some of the other boards and board systems that are out there. And Thomas, I think we all wish you the very, very best of luck with your endeavours. Thank you very much indeed.